Welcome again. This video is in continuation with the previous video. Actually, the last video was interrupted, and now we shall discuss the question about the change in the resistivity of the conductor with the change in temperature. So, let us start the discussion. So, whenever the temperature increases, the first thing that happens is the thermal velocity of the electrons increases. As we know, the thermal velocity of the electron is proportional to the under root times some constant multiplied by kT. Actually, it is 3 kT upon some m kind of thing. So you need not to bother about the exact formula. All we need to understand the proportionality. As in the previous lecture, in the previous live session, I have discussed with you that electrical engineering and electronics engineering is all about understanding the proportionalities, how one quantity is changing with the change of other quantities. So here we can conclude velocity is proportional to the under root times t. So if the temperature increases, that velocity also increases, which is the thermal velocity. In the uh, terminology related to the kinetic theory of solid, that velocity is also called the RMS velocity of the electrons. Okay. So first point is clear. The thermal velocity increases whenever we increase the temperature. Whenever we elevate the temperature, then the thermal energy is imparted, and as a result the thermal velocity of the electrons increase. And when the thermal velocity of the electrons is increased, then time between two collisions decreases, and that time is also called the relaxation time. Actually, this relaxation time is the terminology related to the kinetic theory of solids. The time between two collisions is called the relaxation time. So as we know, if the velocity increases, and we know the formula equal to v equal to distance upon time. This is the basic formula, and we know it by basic mathematics. So if the velocity increases, then if the and if the distance is more or less the same, then the time decreases. So if the time between two collisions decreases, then there will be more number of collisions, because if the average time between two collisions, let us take some numerical values. If the average time between two collisions was the 2 seconds, let us suppose it was 2 seconds, and we are calculating the number of collisions in 60 seconds, then there will be 30 collisions. Okay, and if that time is decreased and now this time is 1.5 seconds, then in 60 seconds there will be 40 collisions. This is pure mathematics, you can understand this. And if the time between two collisions decreases, then the number of collisions will increase. And if the number of collisions between electrons and atoms, what are these collisions? These are the collisions of between vibrating atoms, between vibrating atoms and these vibrating and electrons. So if the collisions between vibrating atoms and electrons increase, then the randomness of the system will increase, and the randomness of the system will increase. There will be hindrance in the movement of electrons, because initially the electrons was like this, and the electrons was like this, it was moving and having some collisions, and now there will be more collisions like this. After the increment of the temperature, there will be more and more collisions, and the electrons will move very randomly, and it will result the decrease in drift velocity, because drift velocity is the velocity imparted by the electric field. So whenever the electric field is applied, let us suppose electric field is applied and electrons are moving, so the drift velocity will decrease. Why? because the randomness of the system is increased. The electron which were supposed to move freely is getting more collisions, and the effect of electric field is decreasing because thermal velocity is increased, as we have already discussed in the previous lecture. The thermal velocity and the velocity imparted by the electric field. But as we have seen, the increment of temperature will increase the thermal velocity. So if the electron is there, if the electron is there, then there are two kinds of velocity it has. One is the thermal velocity, so and one is the force. One is the drift velocity. But increment in this velocity will decrease the effect of this field, because this field is increasing, the field is applying the force F equal to QE. So the increment in the thermal velocity will reduce the effect of the electric field. So electron will more and more collide, and the displacement will be less, than the previous situation. The previous situation was that when the temperature was not elevated, so the displacement will be less, and the electrons will get more and more collisions. So here you can understand this. So the randomness of the system increases, and whenever the randomness of the system increases, the drift velocity decreases. Okay, now next point. Okay, next point is which result in decrement in drift velocity. So okay, let us revise. Up till now, the first thing was the increment in the temperature or elevation in the temperature. Whenever the temperature is elevated, there is thermal energy imparted. So there is thermal energy imparted. So what really happens? That thermal energy increase the thermal velocity of the electrons, and if the thermal velocity of the electrons are increased, then the collisions will increase. Why? Because the time between two collisions will decrease, because time is dependent on the thermal velocity. Okay, and which results which creates the more randomness of the system. And one more thing that you need to understand, which will create the randomness of the system. Here you can see the molecules, the atoms are vibrating at their mean position, and electrons are there. You can see electrons are there. There are many electrons which are moving. This is electron. These all are electrons which are moving randomly inside the material. Here you can see many electrons are colliding. Now what happens whenever we elevate the temperature? Whenever we elevate the temperature of any solid conductor, so the energy is imparted in the electrons. Kinetic energy is imparted in the thermal energy imparted in the electrons shows itself as the kinetic energy. So the electrons are moving. The thermal energy imparted in the electron shows itself as a kinetic energy, and hence it will increase the RMS velocity. And what does that thermal energy do to these atoms which are vibrating? Actually, the energy is also imparted in these atoms. And what really happens if this atom is vibrating like this, and whenever the temperature is increased, then the thermal energy imparted in the the thermal energy imparted in the atom shows itself as a vibrational energy. As we know that atoms are vibrating, you can see every atom is vibrating at their mean position, and when the temperature is increased, then more thermal energy is given to the atom. Then the amplitude of the vibration increases. So initially it was this, and now it is this. The amplitude of the vibration also increases, and this will create more randomness. Again, the collisions will be more, because already electrons are moving with a rapid speed with the thermal velocity, and the thermal velocity is also imparted in the atoms, and that energy is showing itself as a vibrational energy, so there will be more vibrations. So hence we can conclude the increment in the temperature will decrease the drift velocity. At this up till the this point we have explained everything. So now we will come to the next point. So the next point is this: hence the conductivity decreases. So now we know the direct mathematical relationship between conductivity and drift velocity. By this relationship we are already familiar. You need not to bother about these formulas. This tau is the relaxation time, and these all formulas are from the Drude model of the. Actually I have already told you the mathematical explanation with the derivation of formula is very easy, but unfortunately this is not in our syllabus and it is not recommended. We need to understand things qualitatively, and we are doing it fine. So actually so here we are trying to understand things qualitatively, what is really happening. The randomness of the system is increasing, so there will be more hindrance in the path of electrons, because the vibration will increase, so there will be less path to move for the electrons, and by this we can get the idea of decrement in the drift velocity. And now you can directly see the relation J equal to sigma is the conductivity, sigma E is directly proportional to the drift velocity. Here with the help of this relationship you can understand. So if the drift velocity decreases, then the conductivity will also decrease, because all these things N, E and all other things are constant for a particular material. Okay, so now we shall come back to our original slide. So here the point is this: hence the conductivity decreases in, and we know that conductivity is inversely proportional to the resistivity. Conductivity is inversely proportional to the resistivity, and if the conductivity will decrease, then the resistivity will increase, and if the resistivity will increase, this will result the increment in resistance. Why? Because we know the very famous formula R equal to rho L upon A. If the length is constant, area is constant, then we can understand the conductivity, if the resistivity increases, then the resistance will also increase. So this is what happens when we increase the temperature, and the same kind of explanation can be given to the decrement of the temperature. Okay, so this is a homework for you. So whenever the temperature, so here again let me recapitulate. Okay, temperature increases. Okay, what really happens? The temperature increases, the velocity increases, thermal velocity increases, and the time between two collisions decreases, and if the time between two collisions decreases, the number of collisions increases. Also the vibrational energy of the atoms increases, and their amplitude will also increase. So the randomness of the system increases, which results in decrement in the drift velocity. So there will be more hindrance in the path of electron, and electron will get more distracted instead of moving in the influence of the electric field. Okay, and as a result we can see there is a direct relationship between the conductivity and drift velocity and conductivity and mobility, all those things that we have already studied in the previous lecture. So as a result the conductivity decreases, and we can conclude the resistivity increases when the conductivity decreases, and as the resistivity increases the resistance will also increase. Okay, let me put it here. This is the temperature increases, V thermal increases, and the V thermal increases, collisions, number of collisions increases, V thermal increases, the relaxation time decreases, and then the number of collisions increases, and the number of collisions increases, and then the randomness of the system increases, which results in the decrement in the drift velocity. Drift velocity decreases, then the resistivity decreases, and resistivity decreases, the conductivity decreases, and the resistivity increases, and if the resistivity increases it will result in the increment of temperature. And same kind of explanation for the decrement of temperature can be given. Okay, if the temperature decreases, what happens? The V thermal decreases, then the tau increases, and if the tau increases number of collisions decreases. If the number of collision decreases, then the drift velocity will increase. Drift velocity will increase, and if the drift velocity will increase, then conductivity will increase, resistivity will decrease. If the resistivity will decrease, then the resistance will also decrease. So this is the answer of the question that we have asked in the previous lecture. Okay, now you can see some of the formulas related to the kinetic theory of the solids. Here you can see the direct relationship between tau and sigma. Sigma is the relaxation time, and tau, and if the tau decreases, sigma also decreases, because this n square m is a constant term. Okay, constant terms related to the electrons, number of electrons, charge of electron, mass of electron. So this is all constant. Okay, and this is called the Drude model. Actually the mathematical explanation of Drude model is not in our syllabus, but in order to explain the conductors and the change of the resistance of the conductors with the change in the temperature, we need to introduce some qualitative part of this Drude model. Okay, and again you can see these more of these formulas, so I will send you these slides. Okay, I hope the explanation is clear to you. Here you can see the increment. This diagram is related to the increment in the vibration amplitude of the vibration of the atoms as we increase the temperature of the solid. Okay, now let us try to solve some problems. So first problem is a copper wire of 2 mm diameter with conductivity of 5.8 into 10 raised to the power Siemens per meter. So this is the unit of one more standard unit of conductivity. Actually we have seen mho per meter. We have discussed the unit of conductivity mho per meter, and there is one more unit which is equivalent to mho per meter, Siemens per meter. And so here you can see the Siemens is the same Siemens. You have seen the company Siemens, okay, the German company Siemens. So here the word is same, okay. And let us try to solve this problem. What I would suggest you to pause the video and try to solve these problems by yourself. And in case if you are not able to solve the problem, then again continue the video, you will get the answer. Okay, so now let us try to solve the problem. A copper wire of 2 mm diameter, okay, copper wire of 2 mm diameter. So diameter is 2 mm. I won't do the calculations, I will give you just the formula. You will do all the calculations by yourself. 2 mm diameter with the conductivity of 5.8 into 10 raised to the power 7. So sigma is 5.8 into 10 raised to the power 7 Siemens per meter. So actually this is in meters, so you can change it in the meters. 2 into 10 raised to the power minus 3 meters, as we can change mm to meters. Okay, and next what is given? An electron mobility of 0.0032 meter square volt second. So the here MKS units are used, so we will write down the mobility mu equal to 0.0032. Okay, and next what is given? And is subjected to an electric field of 20 millivolts per meter. The applied electric field E is 20 millivolts. 20 millivolts per meter, volt per meter. As we know, the unit of electric field here milli is there, so you can make it volt per meter by multiplying 20 into 10 raised to the power minus 3. Milli is minus 3 volts per meter. Okay, so this is given to us, and now let us try to understand what is asked. The charge density of free electrons. The charge density of free electrons, as we know, the charge density is n, number of electrons per unit volume is called the charge density. So here we need to find the n. As we know, the sigma equal to n e mu. This is the formula which is known to us. Sigma is given, mu is given, e is the charge of electrons, and you can calculate n very easily. Okay, do it yourself. I won't do any calculations for you. Okay, and the second thing is the current density. So current density very easily we can calculate. J equal to sigma E. Sigma we know that conductivity, E is given. What is the field value? it is given 20 millivolt. Okay, the field value of field is given, electric field is given. We can calculate the and the next thing is this: the current flowing in the excuse me, the current flowing in the wire. Okay, current flowing in the wire. So we need to calculate the I we know that I equal to J times A. Current equal to J times A, because current density is the current flowing in the per unit area, and J we have already calculated here, and this A you can calculate with the help of given diameter, because the cross section area of a wire is always circular, and the diameter is given, and we can calculate the area by the pi r square, and r is d by 2. A is pi r square and r is d by 2. Calculate it by yourself. And do these calculation with the help of calculator. Okay, the electron drift velocity, the electron drift velocity, the electron drift velocity. Now Vd equal to mu times E. Minus is there, actually minus is just showing the direction of drift velocity, and the electric field is opposite. So mu is given and E is given, and then we can directly calculate the drift velocity. Here you can see mu is given and E is given. Okay, so this is how we can solve this problem. And now the second question is for you can do it by yours. This is a very easy question. Try to solve this problem and try to find out the answer. Okay, here we shall conclude this lecture. Okay, and in the next lecture we will try to understand the band theory. How does the band creates, how does the band theory is created in the conductors, semiconductors, and with the help of band theory we will try to understand these conductors, semiconductor, etc. Okay.